Hello, everyone. Welcome to our next podcast. It's called From Theory to Practice, the journey of an AI innovator with Dr. Zhou. Hello, Dr. J. How are you doing?
Hello, Tim. I'm good. Thank you for having me, and thank you, everyone.
Okay,
It's
thank
my
you so
honor
much.
to be here.
Thank you so much. Okay, first question. To start, could you share with our listeners the journey of your career, touching on your transition from academia with a Ph.D. in artificial intelligence from the University of Connecticut to becoming a renowned data scientist and entrepreneur?
Absolutely. I came to the United States in 1995 from China. I came here to pursue my Ph.D. from the University of Connecticut, and my area of study is remote sensing image classification. Basically, we try to identify land use type like a city or road or a cornfield from satellite image. I got my degree pretty fast within 3 years. And I tried to get a job in the field. Once I had the interview, I drove 1,000 miles to Ohio from Connecticut. When I came back, I got a phone call. The human resource from the company asked me if I had a green card. At that time, I didn't have green card, and for that kind of job, uh, it often required a green card or citizens. So instead of working in remote sensing industry, I submit my resume to other commercial industries, and I was hired by Nestor, my first company. This company was co-founded by a Nobel Prize winner. His name uh, is Liang Cooper. He won Nobel Prize in physics, but then he invented uh, AI technology, neural network, a special type of neural network, and apply it to solve fraud detection for banks. So I worked there for 3 years to help banks detect transaction fraud. Then I moved to my second company, Lightbridge in Massachusetts. And the first company was in Rhode Island, in USA. Massachusetts is next to Rhode Island. In this new company, I help telecommunication company um, create a credit score for their customers, and we helped a lot of like tens of millions of consumers every year to get their cell phone service. And then after that, I worked for bank as a vice president, and I work as technical staff for Oracle. So I found it's a pretty exciting journey. From a surface, it may be seemingly very different fields, from remote sensing to banks to telecommunication. But actually, to me, it's the same technology. It's about data, regardless it's remote sensing or other financial data. We use the same technology to analyze data to derive meaningful insights and drive our decisions. That's my journey. And after 2016, I became entrepreneur. I'm running my own business. Also, I provide a training service. I enjoy both doing and teaching. Thank you.
Fantastic. Thank you so much. So throughout your career, you've worked in a variety of roles across different sectors, from being the chief statistician at Lightbridge Inc. to founding ZSAnalytics. How have these diverse experiences shaped your approach to data science and business?
That's a great question. It shaped my methodology greatly. Firstly, as we said, different industries, they share a lot of common theme, such as data, right? At the end of the day, business just ways of collecting data and store them in data warehouse. It's the same technology to analyze them and then take advantage of them to help management make decision. So I have no trouble moving from one industry to another quickly. Plus, I found there's an added benefit. For example, I learned from banks credit scoring of consumers. I take that methodology to sports industry. I can score athletes based on many variables like their performance, how they train, their speed, their acceleration. Then I can create a score. Those scores could be indicating they will get injured or not. There will be potential great players. That's the things that we can learn from bank industry. So credit scoring, we can expand that to any other fields. Another example is in bank, we have fraud detection. We use machine learning to automatically detect 95% of fraud, then 5% tough ones has to be reviewed by analysts. So I took same method, I applied to education industry, and I improved their efficiency by 20 folds.
Wow, fantastic. So on that note, you've managed to achieve over $200 million in savings for your clients through your solutions. Can you discuss one or two projects that were pivotal in reaching these impressive figures?
Yes, thank you. I have two projects that I felt very exciting. The first was many years ago, a top mobile phone company asked our company and another famous company who has hundreds of statisticians to build the best consumer model for mobile phone industry. Everyone in our company thought we would lose this competition because I was practically the only guy there working on this project. I mean, those statisticians in our competitors, they may have tens or even hundreds of them. But at the end of the day, the client actually choose the model that I developed. So that was very exciting. So my employer considered analytics was one of our core competence, and we expanded our group. And because it's a huge mobile phone company client, they process tens of millions of consumers. As a result, my model had a great impact. Another example is for a top bank in the United States. I cut their fraud loss by 70%. That's amazing because that's a lot of money every year.
Yeah.
And the best thing is because the bank now see this fraud prevention group was very efficient, creating value. So the bank hired 2 more analysts.
Wow.
Added to this group. So that's a testimony of AI actually increase the job, not reducing job, because it increases value of everyone. That's quite counterintuitive, but it makes sense.
Completely, yes. So winning all the head-to-head competitions to build the best predictive models is no small feat. Can you share your strategy or a critical insight that contributed to these victories?
Yes, there are a number of factors. I think the most important one is feature engineering. This is a process of taking the variable, the original variable. For example, if we are dealing financial fraud transaction, we have location and the timestamps of the transaction. And then based on that, we can create almost unlimited number of variables that are more interesting and more indicative of fraud than the original variables. So I spent a lot of effort in that front. For example, to predict our healthy, we have our height and weight, but those two variables are not too good. If we produce BMI, body mass index, which is like a ratio between height and weight, that BMI is a very good indicator of us being healthy.
Yeah.
So that's a story about feature engineering. I remember once I had an interview with a big bank. The hiring manager gave me a report. He said that he hired 2 consultants to detect fraud, and they spent weeks to produce this report. He asked me to read the report in 10 minutes and give him feedback. So what I read the report, the conclusion drawn by the consultants was that a fraud cannot be predicted because it's so hard. And their methodology is precisely, they didn't do feature engineering. They look at each transaction in isolation. So I pointed out this problem with the hiring manager. I said, if we build feature variables based on time sequence of those transactions, not look at each transaction in isolation, we could detect fraud. And it was very impressive. The manager immediately promote this position from a lower assistant vice president to vice president and increased the salary by 30%, and I was hired.
Brilliant. Well done.
So yeah, that's an example.
Fantastic. So as an adjunct professor at Yeshiva University, you've taken your practical experience into the classroom. How do you translate complex real-world data science problems into teachable moments for your students?
Yeah, absolutely. I thought about this teaching in college this way. In our modern world. Today, we have all those knowledge available through YouTube, through ChatGPT and Google, right? They can search any topic on AI. They can find the 50 or 20 best videos given by professors in many colleges. Google provides answers, of course. So I was asking myself, what value do I add to the classroom as a professor? Yeah. So I figured out that I have practical experience. I have those insights and principles, most importantly, that I derived from my projects that are, time lasting, cross space, time, and domains. So I teach those principles. I don't talk a lot about technical details because those AI tools, they solve those technical issues largely, right? We can even ask ChatGPT to write a code for us. Our principles are important, and if students, they master those principles derived from practical work, then they know how to apply them, and their focus will be on higher level principles, not on details. I have found it worked well, and the students love them. They have more interest, and also they are more motivated to learn.
Cool, thank you. So the founding of ZSAnalytics, Frisian and Strike LLC, and your involvement with the Boston Institute of Analytics highlight your entrepreneurial spirit. What drives you to create and innovate within the tech and educational sectors?
Yeah, I feel that in my over 2 decades of actual work, I have accumulated a lot of practical strategies, like street smart, not taught in textbook or by professors. Also, I found a lot of teachings. There are two techniques focus on those details, which are, as we said, largely solved by modern tools like a Copilot, like ChatGPT.
Right. Yeah.
We should be focusing on those principles derived from actual projects. So I took those principles. I teach at a very high level. I describe the problem, focus on problem, how to translate into a high level solution. And lastly, it's about how to write Python code. So it's like a top-down approach instead of learning Python functions. Then if we do that, do bottom-up approach, we will lose the focus, and we may even lose interest because those details can trap us. So by combining those practical work principles with technology, I found that my teaching is well received by students.
Thank you. Thank you so much. So your work has not only been about creating solutions, but also about education and also mentoring. Could you share a particular memorable mentorship experience that stands out to you?
Yeah, absolutely. Also, I think the learning and doing and mentoring, they are one thing, because as I mentor students or other younger data scientists, I'm learning myself. It forced me to have a clear mind about what I have done, what I've learned, so that I'm able to translate those knowledge into language they can understand. So it helped them and helped me too. And also I have seen great transition from my students. One example is my nephew. He come to the United States as a high schooler. He didn't go to a very expensive college. It's better than community college, but in the tuition is affordable. And I mentored him. I regularly showed him those data science work, how exciting data is. Then he got into data science, and after graduate from that college, he got analytics program master degrees from college, and eventually today he is working for a huge company as a data scientist.
That's great.
And he is making a lot of money. In the past, when we gather together, it's always me paying the bill. But now when we had lunch together or dinner together, there he always grab a wallet and pay the bill. That's
fantastic.
Success.
That's definitely success.
Example is sometimes my friends, my clients, send their kids in the summer to me to guide them. And once I convinced a very good computer engineer student to a data science mind, after those 2 months of summer, he developed a strong interest in data science. And I think combining his computer software skills with data science mind will make him very successful in his career.
Oh, cool. Very good. Very good. So you've been part of significant advancements in AI and machine learning. Looking back, which of these advancements do you find the most transformative and why?
Yeah, there are many, but two things I personally feel very transformative. One is deep learning neural networks, particularly the convolution neural network that for image processing. Back 30 years ago, when we do image processing, it's very hard to identify even a letter in an app. I remembered once I worked for a company, a whole division was devoted to recognizing license plate in our car, try to extract the numbers from the plate. It was so challenging. But today, everyone can write a few lines of Python code and build your machine learning model and do a decent job. It's amazing. Also, generative AI, so we can take advantage of like ChatGPT or Copilot to even write code for us. And those tools largely solved the burden of memory and even understanding and relief us from those burdens. So we have more time focusing on problem and drive business value.
Fantastic, fantastic. So your career is a testament to the power of data analytics across various industries. Can you share your vision for the future of data analytics and its role in business and society?
Absolutely. I believe the machine learning data analytics solution will be everywhere to drive most of our decision. If we look at today's business, in many companies, we still use the same way, means use human intuition, experience to make decision. I mean, those method has been used for hundreds of years, maybe thousands or millions of years, right? And they are flawed. A lot of time we have proof that a data-driven method is far more efficient, and it can help us gain insight that we never had before. An example is that in mobile phone consumer domain, people intuitively think that a consumer with bankruptcy in his past credit history is a bad thing. If I have bankruptcy record, I will not pay my phone bill on time. But the data-driven model, based on the actual data, have found that for those people, they pay bill on time. They are better than even average mobile phone consumers. The reason we are not sure, but that's the data discovered. So I build those machine learning model and give those people with bankruptcy a best decision A class as mobile phone users. As a result, we uncover those underserved people, and the company increased their revenue. So this shows the power of data-driven decision making, and it will be applied in many places. Maybe in 95 of cases, the remaining 5 will be driven by human decision. That's a trend, I believe.
Completely, yeah. So lastly, maintaining a balance between a demanding career and personal interests can be challenging. So how do you manage this balance? And how have your personal interests like soccer and boxing influenced your professional life?
Yeah, hugely. I learned a lot from sports. For example, when we play soccer, I used to be the striker. I always want to score myself. And then later I found that if I play the midfield, I pass the ball. I can pass to the best strikers if he's at the best position. As a result, as the team, we can score more goals and easily. So this tells me about the teamwork. Another example is boxing. It takes a lot of courage to step into the ring and fight with a stranger in front of hundreds of audience, and you may get beaten up. You don't know what will happen. It's a huge psychological barrier to overcome, and many boxers practice for like over a decade. they didn't step into the ring. But I have found that once I overcome that barrier, it helped me gain confidence. Public speaking is nothing in comparison to that kind of scenario. So it helped me boost my confidence, and also helped me learn how to resolve confrontation or conflicts, how to deal with people, things like that. Yeah, definitely help my project. And I didn't take a sick day leave much or not at all. I think it's good to have a foundation of health because it supports every activity.
Oh, fantastic. No, really enjoyed the chat with you today. It's been very insightful, educational, and inspirational. Definitely, we should be doing something in the future again. So have a great day, Jay, and talk to you very soon.
Thank you, Tim.
Thank
Great
you.
to see you. Bye.
Bye-bye. Bye.